Hello students, I hope that you are good, well and fine. So in today's session, we will be seeing methods of solving first order, first degree differential equation. I hope that you remember what do we mean by order, what do we mean by degree of a differential equation. Clear? As we have already seen, what do we mean by order and degree, and also we have seen particular solution and general solution of a differential equation. Okay. So if you do not remember, if you having any type of confusion, so please refer my old videos. Okay. Now for this session, we will be mainly focusing on methods of solving first order, first degree differential equation. That's it. So the first method is differential equation with variable separable. This means what? That you are having, so first order first degree derivative means, sorry, differential equation means you will be having your equation in this form. Yes, y prime or dy over dx is equals to some expression. This f, capital F xy says that this is your expression in terms of x as well as in terms of y. Okay, clear? Okay. And if this expression is also a special kind, what kind? That it can be expressed as a product of two terms or two other functions, gx and hx. Okay, where gx is a function in terms of x and hy is a function in terms of y. Okay, then you can easily solve your differential equation by just using integration. How? Suppose, so this is, first of all, what are the conditions for you? That we are only talking about first order, first degree differential equation. First order means that the highest times the derivative given to us is just one. This means first order derivative, which is dy over dx or y prime, and its degree, the highest degree will be what? 1. So your in general equation for the first order first degree will be of this form. First, this thing must be clear to you. Okay, and then if this capital Fxy, which is your expression in terms of x, in terms of y, okay, in terms of both, and if this can be rewritten as product of a function, product of two function, one function is in terms of x, another is in terms of y, completely in terms of y. Okay, clear? Then if hy is non-zero, then you can write this equation as like this, that dy divided by hy is equals to gx multiplied with dx. And now integrate both sides, you will get this expression is totally in terms of y, and you are integrating in terms of y also. So this means whatever the answer you will get, we are assuming it to be capital Hy, and for this we are assuming it to be capital Gx. And also, if you remember, the indefinite integrals, we always add some constant. Okay, so C will be our arbitrary constant. Clear? As I have already told you, that capital Hy and capital Gx will be the antiderivatives of 1 by hy and gx respectively. So by example, let me show you what do we mean by the above process. So general solution you have to find for this differential equation. As you can see, this right hand side expression is in terms of x as in terms of y also, but you can easily separate them or rewrite your equation like this, that 2 minus y multiplied with dy, sorry, and x plus y multiplied with dx. You can write it. Now integrate both sides. You know the integration of this. This will be 2y minus y square by 2. 2y minus y square by 2. For this, x square by 2 plus x plus some constant c1. Now, simplifying things, you will have multiply with 2 both sides. You will get x square plus y square plus 2x minus 4y plus 2c1 is equals to 0. Now, this 2c1, c1 is some constant. 2c1 is also going to be some constant. This means we are taking another notation for that, which is capital C, where capital C is 2c1. Okay, so this means x square plus y square plus 2x minus 4y plus c is equals to 0. This will be your general solution. Okay, this will be your general solution. I hope it is clear to you. Now, next example, that y prime is equals to 1 plus y square divided by 1 plus x square. As you can see, you can separate your terms. Yes, and you can write dy by 1 plus y square is equals to dxy 1 plus x square. Okay, now this means what? As you can see, integrate both sides. You will get this as tan inverse y, this as tan inverse x plus some constant. Okay, so far so good. So this will be your general solution of the given equation. Now another example. This differential equation is given to you. Dy over dx is equals to minus 4xy square. Okay, given that, what information you have is y is equals to 1 when x is equals to 0. Okay, this information is given. Then when x is 0, your function value, your y will be 1. Okay, so far so good. Now, as you can see, this right hand side is your expression in terms of x, in terms of y. Can you separate them? Can you product? Okay, yes, you can. You can write minus 4x multiply with yx separately. This means this can be rewritten as dy by y square is equals to minus 4x multiply with dx. Integrate both sides. You will have minus 1 by y is equals to minus 2x square plus some constant. This means y can be rewritten as 1 by 2x square minus c. So this will be your general solution. This will be your general solution. But as you can see, one information is given to you that y is equals to 1 when x is 0. This means plug your values. This means x is 0. This means if x is 0, y is 1. So 1 is equals to 1 by minus c. So this means c will be minus 1. So now this will be transformed into particular solution, which is y is equals to 1 by 2x square plus 1 as c value is minus 1. Okay, so you get the particular solution of the given differential equation. I hope it is clear. Okay. Okay, now next example. Find the equation of the curve passing through the point whose differential equation is this. So you have to find the solution curve. Solution curve means first just nothing, but you have to find the solution for this, and whatever the function you will get, you will say that the function, this function, the solution function represents some curve, and that curve will be your solution curve. Okay, and you are given that function exhibit this property. This means if you plug x is equals to 1, you will get y is equals to 1. Okay. Okay, now the given differential equation can be expressed as dy is equals to x square plus 1 divided by x dx. Okay, now simplify it. You will get dy is equals to 2x plus 1 by x dx. This means integrate both sides. You will get y is equals to x square plus log mod x plus some constant. Okay, and now This represents your solution curve. And also what property it shows, that whenever you plug x is equals to 1, you will get output as 1. This means x is 1, y is 1. So substitute your values. So you will get 1 plus 0 plus c, 1. So this means c will be just 0. So you will get your c value as 0. This means your particular solution will be y is equals to x square plus log mod x. Okay. Next example. Find the equation of a curve passing through the point -2, 3, given that the slope of the tangent, slope of the tangent of the curve at any point is 2x divided by y square. So now, as you can see here, you are not given any differential equation directly, but in terms of words. Question is playing with you. In terms of words, the equation is already given to you. How? The slope of a tangent to the curve means dy over dx. Slope of the tangent to a curve means dy over dx. So dy over dx is given to you as 2x by y square. So 2x by y square will be your, now this will be your differential equation. Now as you can see, you can separate them. So it will be y square dy is equals to 2x dx. Now integrate both sides, you will get integration of y square dy is equals to integration of 2x dx. This means y cube by 3 is equals to x square plus some constant. Now, what it satisfies? It satisfies that whenever x is -2, y will be 3. So apply, substitute x -2, y 3. This means 4 plus c will be what? 3. 4 plus c will be, let me just, yes. So it will be 27 by 3, this, which means 9. So 9 is equals to 4 plus c. So this means c must be 5. So c must be 5. So your particular solution will be what? Y cube divided by 3 is equals to x square plus 5, or another way to represent your particular solution is this. Whatever the way you chooses, you can choose. I hope it is clear. Now, example next. In a bank, principal increases continuously at the rate of 5% per year. In how many years 1000 double itself? So let P be the principal at any time t. According to the given problem, what do you have? The rate. Rate means dp by dt. You are having dp by dt as 5% per year. This means whatever the p, the 5% of p. This means 5 by 100 multiply with p. This means p by 20. dp by dt will be p by 20. Now this will be your equation. Separate them and solve it. You will have log p is equals to t by 20 plus some constant. Now p can be rewritten as log with base e. So p is equals to e power t by 20 multiply with e power c1. So we will be taking this as whole constant, which as c. So p is equals to c e power t by 20. This means what we want? We want that in how many years this 1000 rupee will double itself. So p is 1000 when t is 0. Yes, initially it is 1000. Yes, when t is 0, p is 1000. So you can find your c value. So c will be, put t 0. This means c will be 1000. So c will be 1000. Now what you have to find? You have to find value of t when p will be 2000. So just solve it. You will have t is equals to 20 log base e2. So at After this much of time, you will get your principal value double. Okay, I hope it is clear. Okay, let us move. Now we will be solving 9.3. Okay, 9.3 exercise. If time permits, we will be solving every problem of it. Okay, now find the general solution. As you can see, the variable separation can be applied over here. So dy by dx can be rewritten as, first of all, what we are trying to do is simplify this thing. Why? How? As 1 minus cos x is 2 sin x square by 2. 1 plus cos x is 2 cos square x by 2. This can be reduced to tan square x by 2. And this further can be reduced to dy over dx is equals to sec square x by 2 minus 1. Now separate them and integrate them. You will have y is equals to tan x by 2 minus x plus c. Okay, this is your required general solution. Okay, now for second, quite easy. Just separate them. You will get what? Dy root 4 minus y square is equals to dx. You know the direct integration for this. This is what? Sine inverse y by 2 is equals to x plus some constant. So y by 2 is equals to sine x plus some constant. This will be your general solution of the differential equation. Now third, dy over dx plus y is equals to 1. This means take this y to the right hand side. You will have what? You can rewrite it as dy is equals to 1 minus y dx. Okay. Now again, this can be rewritten as dy by 1 minus y is equals to dx. This means integrate it. You will have, this is just nothing minus, okay, this is nothing but minus log 1 minus y. Okay, clear? Minus log 1 minus y. Here it must be minus somewhere here. Okay, and this will be just egg plus some constant. What constant we are taking? We are taking constant in terms of log. That's it. Okay, log. Now take this log thing to the left hand side. You will get minus log c minus log 1 minus y is equals to x. Now after using log properties, you can write it as log c multiply 1 minus y is equals to minus x. This means you can rewrite it as c multiply 1 minus y is equals to e power minus. Now rearrange your terms. You will get y is equals to 1 plus a e power minus x, where a we are taking as minus 1 by c. Okay, c is some constant, 1 by c will be some constant, minus 1 by c will be another constant, and that I am taking as capital A. That's it. So the required general solution of the given differential equation will be y is equals to 1 plus capital A e power minus x. Now fourth problem. So fourth problem can be rewritten as you can see, sec square x tan y dx plus sec square y tan x dy. This can be rewritten as, take this dy term to the right hand side and tan x, now cross multiply this tan x to the left hand side and this tan y to the right hand side. You will have sec square x divided by tan x dx, which is equals to minus sec square y divided by tan y dy. That's it. Integrate both sides. Okay, putting tan x is equals to t, you will get that your numerator can be replaced by just dt. So this means you will have sec you will have what? Dt by t. So this means log t, this means log of tan x. Okay, this is your what? 1 by t, not definite integral. This must be 1 by t. Okay, don't confuse with it. So this is a just minor error. Okay, now similarly the same approach we will be applying for this term. Same substitution will work. You will get tan. Okay, you will get what? You will get log tan y. Okay, now substitute these value. back to your equation, what you will have, what equation here, not equation, what, okay. So you will have log 10x is equals to minus log 10y plus log c. Clear? Okay. This means log 10x is equals to log c by 10y. This means x is equals to c by 10y. This means 10x 10y will be c. I hope that it is clear to you. As you can see, we have already minus there. Okay, that's why minus sign over here. Okay, I hope that it is clear to you. Okay, let us move to the next problem. So next problem says this. So integrate it. What you will have is, first of all, variable separation we have to apply in order to get the correct form. So you will have dy is equals to ex minus e power minus x divided by ex plus e power minus x dx. Now integrate both sides, you will get y is equals to integration of this whole thing. Now derivate of the denominator, substitute your denominator ex plus e power minus x is equals to t. Now derivate it. You can have what? That the numerator can be directly substituted by just dt. So dt by t, this means log t. This means log of ex plus e power minus x. Okay, you will have y is equals to log of ex plus e power minus x plus some constant. Okay, I hope it is clear to you. Here this is not definite integral. It must be indefinite integral 1 divided by t. Okay, please make it correct. Now sixth problem. 1 plus x square, 1 plus y square. Clear? Okay. Now this can be rewritten as, just separate them, you will have dy divided by 1 plus y square is equals to 1 plus x square dx. Integration of this will be tan inverse y, that's it. And integration for this will be x plus x cube by 3 plus some constant. This will be your required general solution of the given differential equation. Now seventh problem, y log y dx is equals to x dy. Separate them, you can easily separate. Okay, so after separation you will get y log y dy divided by y log y is equals to dx x. Integration both side you will get this as, so this can be solved by using substitution method, and this can be solved just directly. This is your log x mod x, that's it. And this will be your log y, take log y as t. So this will be derivative will be 1 by y, dy can be replaced by just dt. So this means dt by t, this means log t is equals to log x plus log c. So this means log of log y is equals to log cx. This means log y is equals to cx. This means y can be rewritten, this expression can be rewritten as y is equals to e power cx. So this will be your general solution of the given differential equation. Okay, now eighth problem. This, separate the variables accordingly. You will have dy by y power 5 is equals to minus dx by x power 5. So this can be integrated both sides. You will have what? You will have x power minus 4 divided by minus 4 plus y power minus 4 divided by minus 4 is equals to k. Multiply with 4 to both sides, you will get minus 4 to both sides, you will get x power minus 4 plus y power minus 4 is equals to minus 4k. Take minus 4k as your another constant, which is capital C. So your required general solution will be this. Now ninth problem, dy over dx is equals to sin x. Now rearrange the term, or to separate your variables, you will get dy is equals to sin inverse x dx. Now integrate both sides. You know the how to integrate this sin inverse x. You can apply your by parts method. So first of all, left hand side will be y, right hand side we are going to apply by parts. So using by parts, you will have sin inverse x integration 1 dx minus integration of derivative of first, integration of second. That okay, so this will be x, y is equals to sin inverse x multiply with x minus derivative of this will be 1 by divided by 1 minus x square multiply with x. Now substitute, you can substitute this your t. So 1 minus x square t, this means minus 2x or x dx can be rewritten as minus half dt, or in other words you can say that minus x dx can be rewritten as dt by 2. So we are replacing this thing, substituting back. You will get y is equals to x sine inverse x plus integration of dt divided by 2 root t. This can be easily done. Okay, so integration of 1 by root t is t half divided by half. This can be cancelled. So you only left with y is equals to x sine inverse x plus root t plus some constant. This means y is equals to x sine inverse x plus root of 1 minus x square plus some constant. Clear? So this will be your required general solution of the given differential equation. Okay, now 10th problem. This you have to solve. So apply your variable separation thing. You will have sec square y divided by tan y dy is equals to minus ex divided by 1 minus ex. Okay, clear? Okay, now integrate both sides. So the left hand side integration can be done by substitution method. Okay, so take tan y is equals to u. This means you will have the numerator. Okay, numerator can be replaced by just du. So du by dt. So du by u, this means log u, means log of tan y. Okay, now what about the right hand side? So substitution will also work here. So 1 minus ex will be t. So this means derivative will be minus ex dx is equals to dt. This means numerator can be replaced by just dt. Now this means your integration becomes integration dt by t. This means log t. T is what? Your 1 minus ex. This means log of 1 minus ex. Now substitute your value back. You will have log tan y is equals to log 1 minus ex, or always add some constant, plus log c. So log tan y is equals to log c multiply 1 minus ex. So this means tan y will be c multiply 1 minus e power x. This will be your what? This will be your required general solution. So okay, now here we will be doing what? We will be okay. So for each differential equation we have to find a particular solution satisfying the given condition. So here we need to find a particular solution. So obvious thing, first we have to find the normal solution or the general solution. According to the condition we will transform it into a particular solution. So let's see. So separate accordingly. You will have dy over dx is equals to 2x square plus x divided by x cube plus x square plus x plus 1. This means dy is equals to 2x square plus x divided by x plus 1 x square plus 1 dx. Now use the partial fraction concept. Okay, so according to the partial fraction, this form can be correspondingly transformed into this form. Okay, clear? Now rearrange some terms. Cross multiplication. After some cross multiplication, you will get 2x square plus x plus is equals to a x square plus a plus bx square plus b plus cx plus c. Now comparing things, x square, this means a plus b is equals to 2. B plus c will be 1. A plus c will be 0. This means a will be minus c. A will be minus c. Now just easily, you can easily solve. You will get a half. This means b will be minus half. Okay, sorry, c will be minus half. B will be 3 by 2. B will be 3 by 2. I hope that it is clear. Okay, so this means this form can be reduced to this partial form, and this form, after applying the integration, you will get your integration easily. So integration will be half of integration 1 by x plus 1 dx plus half of integration 3x minus 1 divided by x square plus 1 dx. So this integration is just direct log x plus 1, and this integration we can separate. Okay, so this can be rewritten as two different integrals, which is x divided by x square plus 1, and another one will be 1 by x square plus 1. Now this integration can be easily found by just multiply with 2 with the numerator and the denominator, and then you can substitute your x square plus 1 as your t. You will get log x square plus 1. Okay, and for this is your direct integration, which is tan inverse x. Now simplify your thing. You will get, apply the log properties. You will get y is equals to 1 by 4x plus 1 whole square multiply x square plus 1 whole cube minus 1 by 2 tan inverse x plus c. Now condition given to you is when x is equals to 0, y is 1. When x is equals to 0, y is 1. So put x is equals to 0. This will be 0. This will be what? 1, 1, 1. So 1 by 4. Okay. When x is equals to 0. So 0, 0. Clear? Okay. I hope it is clear to you. Okay. So this will be log 1. Log 1 means 0. So 1 by 4 times 0, 0. This is 0. So c will be just what? 1. C will be just what? 1. Okay. Y is 1. This is 1, not I. This is 1. Okay. I hope it is clear to you. So your particular solution will be of this form. Clear? Okay. Next problem. Next problem says, so let me just quickly show you the solution for this, and then we will be ending, and the remaining problem we will be seeing in the upcoming session. Now, so separation, after doing the separation, you will have dy is equals to 1 by divided by x minus 1 x plus 1. After applying the partial form, you will get this, and from this you will get a b c value as b is equals to half, c is equals to half. Okay, and a is equals to minus 1. Then you can directly integrate it. Integration, after integration you will get this kind of expression, and after applying your condition, when x is equals to 2, y is 0, you will get k square as 4 by 3. This means you can substitute back your k square value. You will get your particular solution in this form. Okay, so this is it for now. Okay, as time is running out, so we have to go. So thank you all. We will be back with more concepts and more problems. Thank you.